Lesson 8.2, Properties of Logarithms, Part 3, Change of Base. So we're still looking at expanding and condensing logarithms, but we're going to go ahead and add in one more property, the change of base formula. So consider log base 2 of 10. Evaluate log base 2 of 10. Remember that a logarithm is asking 2 to what power gives you 10, so we can start by rewriting this as 2 to what power, or 2 to the x equals 10. Think to yourself for a moment, what exponent can I use? It's not going to be a whole number because, of course, 2 to the third would be 8 and 2 to the fourth would be 16. So I know it's somewhere between 3 and 4. But it's not exactly 3, it's not exactly 4. So then we go through the process of rewriting both sides with a common base. 2 and 10, what is the common base between 2 and 10? Now, of course, 10 is 2 times 5, but again, multiplication is not the question. I want to rewrite 10 as 2 to a power, which of course can't be done. 10 is not 2 to a power. There is no common base between 2 and 10. Now, normally what I would do at this point is, if I can't evaluate something by hand, like with a square root, I can evaluate square root of 25, but I don't know what the square root of 26 is, so I'll just pull out my calculator. Well, if I look again at my calculator, there are 2 log buttons. They're right down here. Remember that this one is the common logarithm, log base 10, and this is the natural logarithm, log base e, and this is log base 2. I cannot use the common log or the natural log button to evaluate log base 2. So now I'm kind of stuck. What do I do if I can't evaluate the logarithm by hand and I can't evaluate the logarithm using a calculator? The issue being that the calculator only has logarithms with certain bases. I can only evaluate by hand if I can find a common base. If the base is the problem, then change the base. So that's what our fourth log property is going to be about. Taking a base that's not useful and turning it into a base that is useful. Now, the way we're going to do this is we're going to take the logarithm of both sides. Keep in mind, I'm not multiplying by the logarithm, I'm not dividing by the logarithm, I'm not adding the logarithm. A logarithm is an operation, and I'm performing the same operation on both sides of the equation. Now, notice I've used ln here. I could actually use any logarithm I want to, but again, we want to change the base to something useful, and the logarithms that are on my calculator are ln and log base 10. So I could use either the common log or the natural log as the most useful logarithms, and it doesn't matter which one I use. You can use any logarithm in the universe. ln and common log are the ones that are on your calculator. Pick one at random, use that one. I am 100% of the time going to use ln for a very stupid reason. It's 2 letters. Versus log is 3 letters. By using ln, I have a 33% savings in my time, and we're all going to die someday. It'd be nice not to spend our entire lives writing 3 letters when we can write 2 letters. That is legitimately the reason why I'm using ln. So I'm going to take ln of both sides. Again, rules of algebra. Whatever you do to one side, you do to the other side, so I'm going to take the ln of both sides. Now, by taking the ln of both sides, that allows me to apply a log property. I could not apply the log property on the previous step, 2 to the x equals 10, because that's not a logarithm. But if I take the ln of both sides, now I have a logarithm, which means I can take that exponent and bring it to the front. I could not do that on 2 to the x, but I can do that on ln of 2 to the x. Now, the goal is to figure out what that x is. So to get that x by itself, recognize that there's actually multiplication happening right here. So in order to get rid of the multiplication, I will divide both sides by ln of 2. When I divide both sides by ln of 2, x is equal to ln of 10 over ln of 2. And that expression can be written in a calculator. Pull out your calculator, type ln of 10, divide it by ln of 2. I'll give you a moment to grab your calculator and type that in. Let me know what you get. Hopefully that's what you got, 3.321. I believe if you rounded it, it would be 3.322. Important thing to recognize here is that I did not divide 10 by 2. It's ln of 10 divided by ln of 2. Feel free to take a moment and divide 10 by 2 and get 5, and then type in ln of 5 in your calculator. You'll see that you will not get 3.321. ln of 10 over ln of 2 cannot be simplified any further. You can't divide what's inside of the numerator by what's inside the denominator. That's not going to work. So ln of 10 over ln of 2. And that right there is the change of base formula. The idea is log base 2 is not on my calculator. So what I'll do is I'll rewrite it as a quotient of 2 logarithms. It doesn't matter what logarithm I choose. Again, I chose ln. And the original base goes to the bottom, and the original input goes to the top. So log base 2 of 10 is equivalent to ln of 10 over ln of 2. Again, it doesn't matter which logarithm I choose. I could also use the common log of 10 over the common log of 2. If you don't believe me, again, grab that calculator, type log of 10 over log of 2 into your calculator. You should see it come out to 3.321, because the logarithm that I chose on that previous step was completely arbitrary. I could even do log base 7 of 10 over log base 7 of 2. The problem is I can't type that into my calculator because there's no log base 7 button on my calculator. The idea is I can take any logarithm of any base and convert it to a different logarithm of a different base. Let's say the new base is base m. M can be anything, but 10 and e are the most useful choices because they're buttons on your calculator. So let's put that into practice. Using your calculator, evaluate these 2 logarithms. Pause here, play when you're ready. So on the first one, log base 72 of 80 would be ln of 80 over ln of 72. Type that in your calculator, comes out to 1.024. On the second one, I'm going to use ln of 10 over ln of 0.5. Type that in your calculator, comes out to negative 3.321. You may recognize that number as similar to the one that we had in the example earlier. I just like to point this out. 0.5, that's really 1/2. And ln of 1/2 could be expanded into ln of 1 minus ln of 2 using our quotient rule. ln of 1 is of course 0, so that's really ln of 10 divided by negative ln of 2, which is just negative ln of 10 over ln of 2. So it's the same question that we had earlier, but negative. Just like to point that out. All right, here's another one. This time put the calculator away and evaluate. Pause here, play when you're ready. Just in case you're stuck, here's the first step I did. Now, if you're not stuck, let's go ahead and continue all the way through to check your answer. Again, log base 2 of 3 can't do anything with that. Log base 3 of 4 can't do anything with that, and so on down the line. I can't evaluate any of those logarithms individually, but I can rewrite all of them using the change of base formula. Now, when I rewrite all of them using the change of base formula, I notice something very interesting. These are all fractions, and the numerator of one fraction matches the denominator of the next fraction, which means I can cancel them all out. The only thing left is going to be the ln of 2 on the first fraction and ln of 8 on the bottom fraction. So all of this condenses down to ln of 8 over ln of 2. Now again, if I just go straight to dividing 8 by 2 to get ln of 4, I have made up my own rules. There is no such rule that says ln of x over ln of y is equal to the ln of x over y. There is no such rule that allows you to do that, so you cannot make up your own rules. But we can recognize this simply to be the output of the change of base formula. ln of 8 over ln of 2 is the same thing as log base 2 of 8. Any rule that works in one direction also works in the opposite direction. If you recognize that to be the change of base formula, you can simply work backwards to recognize that it was really log base 2 of 8 originally. And log base 2 of 8, 2 to what power gives you 8? Well, that would be 3. Final answer.